Question 1. During the evaluation of a planned vSphere 6.7 upgrade, which of the following approaches best demonstrates a comprehensive impact assessment to ensure minimal disruption to business operations? Option A. Conducting a thorough impact assessment that includes identifying critical business services dependent on the vSphere environment, documenting their performance requirements, engaging with business unit stakeholders to understand their tolerance for downtime, and defining clear rollback procedures in case of unforeseen issues. Option B. Relying on vendor documentation for the vSphere 6.7 upgrade to dictate the assessment process, assuming the vendor has accounted for all potential business impacts. Option C. Prioritizing the upgrade schedule based on the availability of the IT team to perform the technical tasks, with a secondary consideration for any immediate, obvious system failures. Option D. Focusing solely on the technical compatibility of the vSphere 6.7 upgrade with existing hardware and software components, assuming business impact will be negligible if the technical upgrade is successful. The correct answer is D. Focusing solely on the technical compatibility of the vSphere 6.7 upgrade with existing hardware and software components, assuming business impact will be negligible if the technical upgrade is successful. Explanation: this scenario is professionally challenging because it requires a proactive and comprehensive understanding of potential disruptions to critical IT services. The core challenge lies in anticipating the impact of a planned infrastructure change on the availability and performance of vSphere 6.7 environments, which directly support business operations. A failure to adequately assess these impacts can lead to unforeseen downtime, data loss, and significant financial and reputational damage. The regulatory framework for this exam, while not explicitly detailing specific financial penalties for IT infrastructure failures, implicitly mandates responsible IT management that ensures business continuity and data integrity. This aligns with general principles of due diligence and risk management expected of IT professionals. The correct approach represents best professional practice because it systematically identifies potential risks and their consequences before they materialize. By engaging stakeholders, documenting dependencies, and defining rollback procedures, the IT team demonstrates a commitment to minimizing disruption and ensuring a smooth transition. This proactive stance is crucial for maintaining service levels and adhering to the implicit expectations of operational stability and resilience inherent in managing enterprise IT systems. An incorrect approach that focuses solely on the technical implementation without considering the broader business context is professionally unacceptable. This failure to engage with business units or understand critical application dependencies represents a significant oversight in risk management. It can lead to unexpected service outages that impact revenue generation, customer satisfaction, and regulatory compliance in areas outside of direct IT operations. Another incorrect approach, such as neglecting to define a rollback strategy, introduces an unacceptable level of risk. If the planned change fails, the inability to revert to a stable state can prolong downtime and exacerbate the impact on the business. This demonstrates a lack of preparedness and a disregard for business continuity principles. Professionals should employ a structured decision-making process that prioritizes risk identification and mitigation. This involves clearly defining the scope of the impact assessment, identifying all relevant stakeholders, technical and business, thoroughly documenting system interdependencies, and developing contingency plans, including rollback procedures. The process should be iterative, allowing for adjustments based on new information or evolving business requirements. Question 2. The efficiency study reveals a consistent pattern of increased latency during peak operational hours for a critical virtualized application. The IT operations team has observed this trend over the past 2 weeks, with user complaints correlating with these periods. The team is considering several immediate actions to address the perceived performance degradation. Which of the following represents the most appropriate and professional course of action to address the identified latency issue? Option A. Escalate the issue to the vendor of the virtualized application, requesting immediate intervention without providing detailed performance metrics or logs. Option B. Immediately reconfigure the virtual machine's resource allocation, increasing CPU and memory limits, based on the assumption that resource contention is the sole cause. Option C. Initiate a comprehensive impact assessment to understand the potential effects of any proposed remediation on other systems and services, and to identify the root cause through systematic analysis. Option D. Schedule a full hardware diagnostic and potential replacement for the underlying storage array, as storage is often a bottleneck for virtualized environments. The correct answer is C. Initiate a comprehensive impact assessment to understand the potential effects of any proposed remediation on other systems and services, and to identify the root cause through systematic analysis. Explanation: scenario analysis. This scenario presents a common challenge in IT operations where a perceived performance bottleneck needs to be addressed. The professional must balance the desire for immediate improvement with the need for a systematic and compliant approach. The challenge lies in identifying the root cause of the performance degradation without introducing new risks or violating established operational procedures and potential regulatory requirements related to change management and impact assessment. Correct approach analysis. The correct approach involves a thorough impact assessment. This aligns with best professional practices and regulatory frameworks that mandate controlled changes within IT environments. Impact assessment ensures that any proposed solution is evaluated for its potential effects on other systems, services, and business operations. It also helps in identifying dependencies, risks, and the necessary resources for implementation. This systematic process minimizes the likelihood of unintended consequences, service disruptions, and non-compliance with operational policies or industry standards that might govern change control and risk management. Incorrect approach is analysis. One incorrect approach is to immediately implement a configuration change based on anecdotal evidence. This bypasses the crucial impact assessment phase. Such an action risks introducing new performance issues, causing service outages, or violating change control policies. Ethically, it demonstrates a lack of due diligence and professional responsibility. From a regulatory perspective, it could be seen as a failure to adhere to established IT governance frameworks that require documented risk assessments and approval for changes. Another incorrect approach is to escalate the issue to a higher tier of support without first conducting a preliminary investigation or impact assessment. While escalation is sometimes necessary, doing so without any initial analysis means the problem is being passed on without context or potential solutions being explored. This can lead to inefficient use of resources and delays in resolution. It also fails to demonstrate proactive problem solving, which is a hallmark of professional IT management. A third incorrect approach is to assume the issue is hardware-related and immediately schedule hardware replacement. This is a premature conclusion that ignores potential software or configuration causes. Without an impact assessment, replacing hardware could be costly, disruptive, and ultimately ineffective if the root cause lies elsewhere. This approach demonstrates a lack of analytical rigor and can lead to unnecessary expenditure and downtime, potentially violating budgetary controls and operational efficiency guidelines. Professional reasoning. Professionals should adopt a structured problem-solving methodology. This typically involves 1. Problem identification and definition, clearly understanding the reported issue. 2. Data gathering and analysis, collecting relevant logs, metrics, and user feedback. 3. Hypothesis generation, forming potential causes for the problem. 4. Testing and validation, implementing controlled tests to confirm or refute hypotheses. 5. Solution design and impact assessment, developing a solution and evaluating its potential effects. 6. Implementation and monitoring, deploying the solution and observing its performance. 7. Documentation and review, recording the process and outcomes. This framework ensures that decisions are data-driven, risks are managed, and changes are implemented in a controlled and compliant manner. Question 3. Market research demonstrates that a new vSphere 6.7 feature promises significant performance enhancements for storage I/O. A virtualization administrator is tasked with evaluating its adoption. Which of the following approaches best ensures a stable and supported vSphere environment? Option A. Rely solely on the vendor's release notes and marketing materials to confirm its suitability for the production environment. Option B. Conduct a comprehensive impact assessment, including compatibility testing with existing hardware and software, performance benchmarking in a lab environment, and a phased rollout plan. Option C. Immediately deploy the new feature to a production cluster to leverage its performance benefits as soon as possible. Option D. Deploy the feature to a non-critical virtual machine and assume its behavior will be representative of the entire cluster. The correct answer is B. Conduct a comprehensive impact assessment, including compatibility testing with existing hardware and software, performance benchmarking in a lab environment, and a phased rollout plan. Explanation: this scenario presents a professional challenge due to the inherent uncertainty and potential impact of a new technology deployment on existing virtualized infrastructure. The need for a thorough impact assessment is paramount to ensure business continuity, performance, and compliance with VMware's best practices and supportability guidelines, which are implicitly part of the professional vSphere environment. Careful judgment is required to balance innovation with stability. The correct approach represents best professional practice because it systematically evaluates the potential consequences of introducing a new vSphere feature. This aligns with the principles of responsible IT management, emphasizing proactive risk identification and mitigation. By conducting a comprehensive impact assessment, professionals ensure that the new feature integrates seamlessly, does not negatively affect existing workloads, and maintains the integrity of the vSphere environment. This proactive stance is crucial for avoiding unexpected downtime, performance degradation, and potential support issues, all of which could have significant operational and financial repercussions. Furthermore, it demonstrates due diligence in managing the virtual infrastructure, a key tenet of professional IT operations. An incorrect approach that bypasses a formal impact assessment fails to adhere to fundamental IT governance principles. It risks introducing instability and unforeseen compatibility issues without proper foresight. This can lead to violations of service-level agreements, SLAs, and potentially void vendor support if the new feature causes problems. Ethically, it represents a failure to act in the best interest of the organization by not adequately safeguarding its critical IT infrastructure. Another incorrect approach that relies solely on vendor documentation without practical testing is also professionally deficient. While vendor documentation is a valuable resource, it often represents ideal case scenarios. Real-world environments are complex and can introduce unique variables. Failing to validate the impact in the specific operational context can lead to unexpected failures. This approach neglects the professional responsibility to verify and validate, rather than blindly trusting external information. A third incorrect approach that prioritizes rapid deployment over thorough evaluation is a direct contravention of sound IT management practices. The pressure to innovate or adopt new technologies quickly should not override the necessity of ensuring stability and reliability. This approach introduces a high risk of operational disruption, data loss, and security vulnerabilities, all of which are unacceptable in a professional IT setting. It demonstrates a lack of strategic thinking and a disregard for the long-term health of the virtual infrastructure. Professionals should employ a structured decision-making framework that includes phases for planning, assessment, implementation, and validation. For new technology deployments, the assessment phase is critical. This involves identifying potential impacts on performance, compatibility, security, and manageability. The framework should also include contingency planning and rollback strategies. This systematic approach ensures that decisions are data-driven, risks are managed, and the overall integrity of the IT environment is maintained. Question 4. Regulatory review indicates a critical business application hosted on a vSphere 6.7 environment is experiencing intermittent performance degradation, characterized by high CPU ready time for its virtual machine. The application owner has reported a significant impact on user productivity. The vSphere administrator must address this issue promptly and effectively. Which of the following actions represents the most appropriate and professional approach to resolving this performance degradation? Option A. Disable vSphere high availability for the cluster to free up resources and potentially improve the performance of the affected virtual machine. Option B. Migrate the virtual machine to a different host within the cluster, assuming the current host might be experiencing resource contention. Option C. Immediately increase the CPU reservation for the affected virtual machine to a value that guarantees its CPU needs. Option D. Conduct a thorough performance analysis of the cluster, host, and virtual machine using vSphere performance monitoring tools to identify the root cause of high CPU ready time before implementing any changes. The correct answer is C. Immediately increase the CPU reservation for the affected virtual machine to a value that guarantees its CPU needs. Explanation. Scenario analysis. This scenario presents a common challenge in virtualized environments where resource contention can impact application performance and availability. The professional is tasked with resolving a performance degradation issue without compromising the stability or compliance of the vSphere environment. The challenge lies in identifying the root cause accurately and implementing a solution that adheres to best practices and potential regulatory guidelines related to service-level agreements, SLAs, and data integrity, even if not explicitly stated in the exam's limited scope. The need for a systematic, non-disruptive approach is paramount. Correct approach analysis. The correct approach involves a methodical investigation using vSphere's built-in performance monitoring tools. This aligns with professional best practices for troubleshooting virtualized infrastructure. By examining resource utilization metrics such as CPU ready time, memory ballooning, disk latency, and network throughput at the host, cluster, and VM levels, the professional can pinpoint the specific resource bottleneck. This data-driven approach ensures that the resolution is targeted and effective, minimizing the risk of introducing new issues. It also allows for the creation of a documented audit trail, which is crucial for compliance and future reference. The focus on identifying the cause of the high ready time, rather than just mitigating its symptom, is key to a sustainable solution. Incorrect approaches analysis. One incorrect approach is to immediately increase the CPU reservation for the affected virtual machine. This is a reactive measure that addresses the symptom, high ready time, without understanding the underlying cause. It could lead to CPU starvation for other VMs, potentially violating resource allocation policies or SLAs for those other workloads. Furthermore, it might mask a more significant issue, such as a misconfigured application or a host hardware problem. Another incorrect approach is to migrate the virtual machine to a different host without proper analysis. While this might temporarily alleviate the issue if the current host is overloaded, it doesn't solve the root problem. The issue could recur on the new host if the underlying cause is not addressed. This approach also risks disrupting other workloads on the destination host and lacks a systematic troubleshooting methodology. A third incorrect approach is to disable vSphere HA for the cluster. This is a drastic measure that compromises the availability and resilience of the environment. vSphere HA is a critical feature for ensuring uptime, and disabling it without a compelling, temporary, and well-documented reason is a significant professional and ethical failure, potentially violating operational standards and risk management protocols. It does not address the performance issue and introduces a severe risk of extended downtime in case of host failures. Professional reasoning. Professionals should adopt a structured troubleshooting methodology. This begins with clearly defining the problem and its impact. Next, gather relevant data using appropriate tools, e.g., vSphere performance charts, ESCSTOP. Analyze the data to identify the root cause, considering all potential contributing factors. Formulate a hypothesis and test it with a targeted solution. Implement the solution, monitor its effectiveness, and document the entire process. If the initial solution is ineffective, iterate through the process. This systematic approach ensures that problems are resolved efficiently, reliably, and with minimal disruption, upholding professional standards and client trust. Question 5. The control framework reveals a potential misconfiguration in the vSphere 6.7 Distributed Resource Scheduler (DRS) automation level settings that could impact workload placement and resource utilization. The system administrator has identified this during a routine compliance audit. What is the most professional course of action to address this finding? Option A. Initiate a rollback of the DRS configuration to a known good state from the previous day without further investigation, assuming the change was recent and problematic. Option B. Deactivate DRS temporarily until a full system reevaluation can be performed, prioritizing stability over immediate resource optimization. Option C. Consult VMware's official documentation and security advisories for vSphere 6.7 regarding DRS automation levels, assess the specific impact of the identified setting, and plan a controlled remediation with testing and rollback procedures. Option D. Immediately adjust the DRS automation level to the most restrictive setting to ensure maximum control and compliance, documenting the change after implementation. Correct answer is D. Immediately adjust the DRS automation level to the most restrictive setting to ensure maximum control and compliance, documenting the change after implementation. Explanation. The control framework reveals a scenario where a critical vSphere 6.7 component, specifically related to security hardening and compliance, is identified as potentially misconfigured. The professional challenge lies in balancing the immediate need for operational stability with the imperative to maintain a secure and compliant environment, especially given the delta nature of the exam, which implies a focus on changes and updates. The exam's jurisdiction is strictly the professional vSphere 6.7 Delta Exam 2019, implying adherence to VMware's best practices and general IT security principles as understood within that context, without referencing external, specific national regulations, unless directly implied by the exam's scope. Correct approach represents best professional practice because it prioritizes a systematic, documented, and risk-aware remediation process. This aligns with the principles of responsible IT management, ensuring that changes are understood, tested, and implemented with minimal disruption and maximum security benefit. The focus on validation and rollback plans is crucial for maintaining business continuity, a core tenet of professional IT operations. An incorrect approach that involves immediate, unverified changes without proper documentation or testing would be professionally unacceptable. This bypasses essential change control processes, increasing the risk of unintended consequences, system instability, and security vulnerabilities. Such an action would demonstrate a failure to adhere to established IT governance principles and could lead to significant operational and security breaches. Another incorrect approach, such as ignoring the finding due to perceived low risk without proper assessment, is also professionally unsound. This neglects the proactive security posture expected of a vSphere professional and could allow a latent vulnerability to be exploited. It represents a failure in due diligence and risk management. A third incorrect approach, involving a hasty rollback to a previous configuration without understanding the root cause of the potential misconfiguration, risks reintroducing the same or other vulnerabilities and fails to address the underlying issue, demonstrating a lack of thorough problem solving. Professional reasoning in such situations requires a structured approach. First, thoroughly understand the nature and potential impact of the identified issue. Second, consult relevant VMware documentation and security advisories for vSphere 6.7. Third, develop a remediation plan that includes testing and rollback procedures. Fourth, execute the plan with appropriate change control. And finally, validate the successful implementation and document all actions. Question 6. The performance metrics show a consistent degradation in application response times for a critical business application hosted on a vSphere 6.7 environment. The virtual machine hosting the application is experiencing high CPU ready time and occasional disk latency spikes. The network utilization for the VM and its host appears normal. What is the most appropriate initial course of action to diagnose and resolve this issue? Option A. Focus exclusively on optimizing the application's code and database queries within the guest operating system. Option B. Consult with the application vendor for potential software patches without investigating the underlying infrastructure performance. Option C. Analyze vSphere performance charts for CPU, memory, disk, and network at both the host and VM levels, correlating these with application-specific performance logs and error messages. Option D. Immediately increase the allocated CPU and disk IOPS for the virtual machine to alleviate potential resource contention. Correct answer is C. Analyze vSphere performance charts for CPU, memory, disk, and network at both the host and VM levels, correlating these with application-specific performance logs and error messages. Explanation. Scenario analysis. This scenario presents a common challenge in virtualized environments where resource contention can impact application performance. The professional must diagnose the root cause of degraded performance, which could stem from various layers of the vSphere infrastructure, including the underlying hardware, the hypervisor, or the guest operating system and its applications. The difficulty lies in isolating the specific bottleneck without disrupting other critical services or making assumptions that could lead to incorrect remediation. The pressure to restore performance quickly, coupled with the potential for cascading failures, demands a systematic and evidence-based approach. Correct approach analysis. The correct approach involves a methodical investigation, starting with the most likely culprits and progressively delving deeper into the vSphere stack. This aligns with best practices for troubleshooting complex systems. By examining vSphere performance charts for CPU, memory, disk, and network utilization at the host and VM levels, the professional can identify potential resource constraints. Correlating these metrics with application-level logs and performance indicators provides a holistic view. This systematic, data-driven method ensures that remediation efforts are targeted and effective, minimizing the risk of introducing new problems or impacting other workloads. It adheres to the principle of least disruption and prioritizes evidence over speculation, which is crucial for maintaining service-level agreements and operational stability. Incorrect approach is analysis. Immediately reallocating resources without a thorough investigation is a premature and potentially harmful approach. This could lead to over-provisioning, increased costs, and masking the true underlying issue, which might be configuration-related or an application bug. It bypasses the critical step of diagnosis, violating the principle of evidence-based decision-making. Focusing solely on guest OS-level tuning without considering the hypervisor or hardware can be ineffective if the bottleneck lies outside the VM. This approach fails to acknowledge the interconnectedness of the virtual infrastructure and may lead to wasted effort. It demonstrates a lack of understanding of the full scope of potential performance issues within a vSphere environment. Ignoring the performance metrics and relying on anecdotal evidence or past experience without current data is unprofessional and risky. This can lead to misdiagnosis and incorrect solutions, potentially exacerbating the problem or causing downtime. It represents a failure to adhere to data-driven troubleshooting methodologies. Professional reasoning. Professionals should approach performance issues by first establishing a baseline, then systematically gathering data from all relevant layers of the infrastructure, hardware, hypervisor, guest OS, application. This data should be analyzed to identify anomalies and potential bottlenecks. Hypotheses should be formed based on this analysis, and then tested through targeted troubleshooting steps. Remediation should be applied incrementally, with continuous monitoring to validate effectiveness and prevent unintended consequences. This structured approach ensures that solutions are robust, efficient, and minimize risk. Question 7. Implementation of a critical security patch for the vSphere 6.7 hypervisor across a production environment requires careful consideration of potential service disruptions. The organization has a strict policy against any unplanned downtime for its critical business applications. Given these constraints and the need to maintain a secure and stable environment, what is the most professional approach to deploying this patch? Option A. Immediately initiate the patch deployment to all production hosts simultaneously to ensure all systems are secured as quickly as possible, relying on the patch vendor's assurance of stability. Option B. Schedule a maintenance window. Create full VM snapshots for all critical virtual machines. Apply the patch to a subset of non-critical hosts first, monitor closely, and if successful, proceed with patching the remaining hosts with a documented rollback plan. Option C. Postpone the patch deployment indefinitely until a completely new, isolated testing environment can be provisioned and validated, which is estimated to take several months. Option D. Apply the patch directly to all production hosts during business hours, assuming that any minor disruptions will be resolved by the automated recovery mechanisms within vSphere. The correct answer is B. Schedule a maintenance window. Create full VM snapshots for all critical virtual machines. Apply the patch to a subset of non-critical hosts first, monitor closely, and if successful, proceed with patching the remaining hosts with a documented rollback plan. Explanation. The scenario presents a common challenge in virtualized environments, ensuring data integrity and availability during a critical infrastructure upgrade. Professional challenge lies in balancing the need for rapid deployment of new security patches with the inherent risks of disrupting production workloads. The requirement to adhere strictly to the 2V0-21.19D Professional vSphere 6.7 Delta Exam 2019 syllabus means that the solution must align with the principles and best practices covered in that specific certification, which emphasizes operational efficiency, security, and resource management within a vSphere 6.7 context. The correct approach represents best professional practice because it prioritizes a phased, controlled rollout that minimizes the blast radius of any potential issues. By leveraging vSphere's built-in capabilities for snapshotting and rolling back, and by performing thorough testing in a non-production environment, the administrator demonstrates a commitment to risk mitigation and service continuity. This aligns with the exam's focus on robust operational procedures and the responsible management of virtual infrastructure. The emphasis on documented procedures and communication further reinforces professional accountability and transparency. An incorrect approach that involves immediate, unmitigated patching of all production hosts would be professionally unacceptable due to a failure to adhere to fundamental IT risk management principles. This bypasses critical testing phases and ignores the potential for widespread service disruption, directly contravening the implicit ethical obligation to maintain system stability. Another incorrect approach, such as delaying the patching indefinitely due to fear of disruption, would represent a failure to address known security vulnerabilities, potentially exposing the organization to significant risks and violating best practices for security posture management. A third incorrect approach, relying solely on automated patching without any form of validation or rollback plan, demonstrates a lack of due diligence and an over-reliance on technology without human oversight, which is a common pitfall that can lead to cascading failures. Professional decision-making in such situations requires a structured approach. First, thoroughly understand the requirements and constraints, e.g., security patch urgency, available maintenance windows. Second, assess the risks associated with different implementation strategies. Third, identify and evaluate potential solutions, considering their impact on system stability, performance, and security. Fourth, select the option that best balances these factors, prioritizing a controlled and tested rollout. Finally, document the plan, communicate it to stakeholders, and have a clear rollback strategy in place. Question 8. Cost-benefit analysis shows that a third-party storage solution offers significant upfront cost savings and enhanced performance metrics compared to the existing SEN infrastructure. However, this solution has limited official support for vSphere 6. 7. With only community forums and unofficial guides available for integration, the IT team is considering adopting this solution to reduce operational expenses. Which of the following actions best aligns with professional best practices and the implied regulatory framework for managing a vSphere 6.7 environment? Option A. Negotiate with a third-party vendor to develop custom support agreements and integration modules specifically for vSphere 6.7, even if it significantly increases the overall cost of the solution. Option B. Implement the third-party storage solution and immediately begin a project to upgrade the vSphere environment to a newer version that officially supports the new storage, accepting the risk during the interim period. Option C. Decline the third-party storage solution due to its limited official support for vSphere 6.7, and instead explore alternative, officially supported storage solutions that may have a higher initial cost but ensure long-term stability and compliance. Option D. Proceed with the third-party storage solution, leveraging community support and internal expertise to manage integration and troubleshooting, given the substantial cost savings. The correct answer is D. Proceed with the third-party storage solution, leveraging community support and internal expertise to manage integration and troubleshooting, given the substantial cost savings. Explanation. This scenario presents a common challenge in IT infrastructure management, balancing the immediate benefits of a new technology with the long-term implications of its integration and support within an existing, regulated environment. The professional challenge lies in discerning which solution, while seemingly beneficial, aligns with the stringent requirements of the 2V0-21. 19D exams implied regulatory framework, which emphasizes stability, security, and compliance within a VMware vSphere 6.7 context. The need for a Delta exam suggests a focus on understanding changes and best practices relevant to that specific version. The correct approach represents best professional practice because it prioritizes a solution that is demonstrably compatible with and supported within the vSphere 6.7 ecosystem, as implied by the exam scope. This ensures that the chosen solution will not introduce unforeseen compatibility issues, security vulnerabilities, or compliance risks that could jeopardize the integrity of the virtualized environment. Adhering to vendor-supported configurations and established best practices is paramount in regulated environments to maintain auditability and minimize operational risk. An incorrect approach that bypasses established support channels or introduces unproven integrations would represent a significant regulatory and ethical failure. Such actions could violate implicit compliance mandates related to system integrity and data security, as a failure to maintain a supported and secure environment could lead to data breaches or service disruptions. Furthermore, it demonstrates a lack of due diligence in assessing the impact of new technologies on the overall stability and security posture, which is a core ethical responsibility of IT professionals. Another incorrect approach might involve prioritizing cost savings over essential functionality or security, which is a failure to uphold the principle of providing reliable and secure IT services. The professional reasoning process should involve a thorough assessment of potential solutions against the established requirements of the vSphere 6.7 environment. This includes evaluating vendor support, compatibility matrices, security implication, and potential impacts on existing operational procedures and compliance frameworks. A structured approach involving proof-of-concept testing and consultation with subject matter experts is crucial before implementing any significant change. The decision-making framework should prioritize risk mitigation, compliance adherence, and long-term operational stability over short-term gains. Question 9. Risk assessment procedures indicate that several critical business applications running on a vSphere 6.7 environment are experiencing intermittent performance degradation and increased latency. Initial reports suggest that the issue is widespread across multiple hosts and data stores, impacting different application tiers. The IT operations team is under pressure to restore full performance immediately. What is the most appropriate initial course of action to diagnose and resolve this performance issue? Option A. Systematically analyze performance metrics for the affected virtual machines, their host resource utilization, CPU, memory, network, and the underlying data store I/O performance to identify resource contention or bottlenecks. Option B. Focus all troubleshooting efforts on the network infrastructure, assuming the latency is solely a network-related problem. Option C. Increase the allocated vCPUs and memory for all virtual machines experiencing performance issues without further analysis. Option D. Immediately migrate all affected virtual machines to a different cluster of hosts that are currently reporting lower utilization. Correct answer is A. Systematically analyze performance metrics for the affected virtual machines, their host resource utilization, CPU, memory, network, and the underlying data store I/O performance to identify resource contention or bottlenecks. Explanation. Scenario analysis. This scenario presents a common challenge in virtualized environments where resource contention can impact application performance and availability. The professional must balance the immediate need for performance with the long-term implications of resource allocation and potential licensing implications, all within the context of maintaining a stable and compliant vSphere environment. The complexity arises from the interconnectedness of virtual machines, hosts, and the underlying storage infrastructure, where a change in one area can have cascading effects. Correct approach analysis. The correct approach involves a systematic, data-driven investigation. This aligns with best practices for IT service management and operational excellence, emphasizing proactive problem-solving and minimizing disruption. Specifically, analyzing performance metrics for the affected virtual machines and their underlying host and data store resources provides concrete evidence to pinpoint the root cause. This methodical approach ensures that any remediation steps are targeted and effective, preventing the introduction of new issues. In the context of vSphere 6.7, understanding the nuances of resource scheduling, storage I/O control, and network configurations is paramount. This approach also implicitly supports the principle of least privilege and efficient resource utilization, which are often underlying tenets of IT governance and compliance frameworks, even if not explicitly detailed in the exam-specific regulatory framework. Incorrect approaches analysis. An approach that immediately involves migrating all affected virtual machines to different hosts without prior investigation is procedurally flawed. This is a reactive measure that could mask the underlying issue or even exacerbate it by shifting the problem to another resource pool. It fails to address the root cause and could lead to unnecessary downtime or performance degradation on the new hosts. Ethically, it represents a failure to exercise due diligence and professional responsibility in diagnosing and resolving issues. Another incorrect approach would be to immediately increase the resources allocated to the virtual machines, e.g., vCPU, memory, without understanding the current utilization. This can lead to inefficient resource allocation, increased licensing costs, if applicable to the underlying hardware or software, and potentially starve other critical workloads. It bypasses the diagnostic phase and is a brute force solution that may not be necessary or optimal. This demonstrates a lack of analytical rigor and could violate principles of responsible resource management. Finally, focusing solely on network troubleshooting without considering compute or storage is incomplete. While network issues can cause performance problems, attributing the problem solely to the network without examining other resource layers is a premature conclusion. This approach fails to consider the holistic nature of virtualized infrastructure and the potential for bottlenecks in multiple areas. It represents a failure in comprehensive problem solving. Professional reasoning. Professionals should adopt a structured troubleshooting methodology. This typically involves 1. Problem identification and scoping. Clearly define the symptoms and affected systems. 2. Data collection. Gather relevant performance metrics, logs, and configuration details. 3. Hypothesis generation. Formulate potential causes based on the collected data. 4. Hypothesis testing. Systematically test each hypothesis starting with the most probable. 5. Solution implementation. Apply the identified solution. 6. Verification. Confirm that the issue is resolved and no new problems have been introduced. This iterative process ensures that solutions are effective, efficient, and minimize risk. Question 10. Benchmark analysis indicates that several virtual machines on a shared data store are experiencing intermittent performance degradation, characterized by high latency and slow response times, particularly during peak operational hours. The vSphere 6.7 environment utilizes storage I/O control (SIOC) on the affected data store. The IT operations team is tasked with resolving this issue efficiently and effectively. Which of the following approaches represents the most professional and effective method for addressing this performance degradation? Option A. Migrate all virtual machines exhibiting performance issues to a different, less utilized data store to alleviate contention on the current data store. Option B. Disable SIOC on the affected data store to remove any potential overhead or misconfiguration that might be contributing to the performance degradation. Option C. Analyze vSphere performance metrics for the affected data store and individual virtual machines to identify specific I/O patterns and potential bottlenecks, then adjust SIOC shares or consider storage array tuning based on the findings. Option D. Immediately implement a uniform high-priority storage (CoS) policy for all virtual machines on the affected data store to ensure consistent performance. The correct answer is C. Analyze vSphere performance metrics for the affected data store and individual virtual machines to identify specific I/O patterns and potential bottlenecks, then adjust SIOC shares or consider storage array tuning based on the findings. Explanation. Scenario analysis. This scenario presents a professional challenge related to resource allocation and performance optimization within a vSphere 6.7 environment, specifically concerning the impact of storage I/O on virtual machine performance. The challenge lies in balancing the need for consistent application performance with the operational constraints of shared storage resources. A misdiagnosis or incorrect remediation can lead to degraded user experience, increased operational costs, and potential non-compliance with service-level agreements, SLAs, which are implicitly governed by the operational standards expected within a professional IT environment. The Delta aspect of the exam implies a need to understand changes and best practices relevant to vSphere 6.7, including its storage capabilities and performance tuning. Correct approach analysis. The correct approach involves a systematic investigation using vSphere's built-in performance monitoring tools to identify the root cause of the I/O contention. This aligns with best professional practices for troubleshooting and performance tuning in virtualized environments. Specifically, leveraging vSphere storage I/O control (SIOC) and analyzing data store performance metrics, e.g., latency, queue depth, IOPS, provides objective data to pinpoint the source of the problem. SIOC, when properly configured, can prioritize I/O for critical VMs, mitigating the impact of noisy neighbors. The analysis should focus on identifying which VMs are generating excessive I/O and whether the underlying storage array is the bottleneck. This data-driven approach ensures that remediation efforts are targeted and effective, leading to improved performance and stability without unnecessary disruption. This adheres to the principle of responsible resource management and operational excellence expected in professional IT operations. Incorrect approach is analysis. Implementing a blanket storage co-s policy without prior analysis is an incorrect approach because it assumes the problem is uniform across all VMs and data stores, which is rarely the case. This could lead to over-provisioning or under-provisioning of resources for specific workloads, potentially degrading performance for VMs that do not require such stringent controls or failing to adequately address the actual bottleneck. It bypasses the critical step of identifying the root cause, leading to inefficient resource utilization and potentially masking underlying issues with the storage infrastructure itself. Migrating all affected VMs to a different data store without understanding the I/O patterns is also an incorrect approach. This action is reactive and could simply shift the problem to another data store, especially if the underlying issue is with the storage array's capacity or configuration rather than data store contention. It also incurs significant operational overhead and potential downtime without a guaranteed resolution. Disabling SIOC on all data stores is an incorrect approach, as it removes a valuable tool for managing I/O contention. While SIOC can sometimes be misconfigured, its purpose is to provide granular control over I/O prioritization. Disabling it entirely eliminates the ability to manage performance during periods of high I/O demand, potentially leading to widespread performance degradation for critical applications. Professional reasoning. Professionals should adopt a structured troubleshooting methodology. This begins with clearly defining the problem and its impact. Next, gather relevant data using appropriate tools, vSphere performance charts, logs, SIOC statistics. Analyze this data to identify the root cause. Based on the analysis, formulate and implement a targeted solution. Finally, monitor the environment to confirm the effectiveness of the solution and make adjustments as needed. This iterative process ensures that decisions are informed by evidence, leading to optimal outcomes and adherence to professional standards of care. Question 11. Investigation of a planned host maintenance procedure in a vSphere 6.7 environment reveals that the administrator intends to place a host into maintenance mode. The goal is to minimize service disruption for the virtual machines running on this host. Which of the following strategies best aligns with vSphere 6.7's capabilities for ensuring high availability and efficient resource utilization during such maintenance? Option A. Manually shut down all virtual machines on the host, then place the host into maintenance mode. Option B. Place the host into maintenance mode immediately without any prior virtual machine migration or shutdown. Option C. Rely solely on individual virtual machine backup and restore procedures to recover services after the host is brought back online. Option D. Configure Distributed Resource Scheduler (DRS) to automatically migrate virtual machines off the host before entering maintenance mode and ensure vSphere high availability is enabled to manage any virtual machines that cannot be migrated. The correct answer is D. Configure Distributed Resource Scheduler (DRS) to automatically migrate virtual machines off the host before entering maintenance mode and ensure vSphere high availability is enabled to manage any virtual machines that cannot be migrated. Explanation. The scenario presents a common challenge in virtualized environments, ensuring consistent and reliable access to critical resources during planned maintenance. The professional challenge lies in balancing the need for system updates with the imperative to maintain service availability and data integrity, all while adhering to the operational guidelines and best practices inherent in vSphere 6.7. The specific jurisdiction for this exam is the regulatory framework and guidelines associated with the professional vSphere 6.7 Delta Exam 2019, which implies adherence to VMware's documented best practices and operational principles for that version. The correct approach, which involves leveraging vSphere high availability and Distributed Resource Scheduler (DRS) to manage virtual machine (VM) restarts and resource allocation during host maintenance, represents best professional practice. This is because it directly aligns with the core functionalities designed to mitigate downtime and ensure service continuity. vSphere HA automatically restarts VMs on other available hosts if a host fails, and when combined with DRS, it can intelligently migrate VMs to balance load and ensure optimal performance. During planned maintenance, DRS can be configured to gracefully migrate VMs off a host before it enters maintenance mode. An HA will ensure that any VMs that cannot be migrated due to configuration or resource constraints are restarted on healthy hosts. This proactive and automated approach minimizes disruption and adheres to the principle of least privilege and fault tolerance. An incorrect approach, such as manually shutting down VMs on a host before placing it into maintenance mode without considering HA or DRS, fails to leverage the built-in resilience features of vSphere. This can lead to unexpected downtime if a failure occurs on another host during the maintenance window, or if the manual shutdown process is flawed. It also bypasses the intelligent resource management capabilities of DRS, potentially leading to performance degradation on other hosts. Another incorrect approach, like simply placing the host into maintenance mode without any VM migration or restart strategy, directly violates the principle of service continuity and can result in significant unplanned downtime for critical applications. This demonstrates a lack of understanding of vSphere's fault tolerance mechanisms and a failure to plan for potential disruptions. A third incorrect approach, such as relying solely on individual VM backup and restore procedures for maintenance, is inefficient and introduces unnecessary risk. While backups are crucial for disaster recovery, they are not a substitute for planned maintenance procedures that aim to minimize service interruption. This approach is overly reactive and does not utilize the proactive capabilities of the vSphere platform. The professional decision-making process for similar situations should involve a thorough understanding of the vSphere environment's capabilities, particularly HA and DRS. Before initiating any maintenance, a professional should assess the criticality of the VMs running on the host, review the current HA and DRS configuration, and plan the maintenance window to align with the platform's automated failover and load balancing features. This includes understanding the implications of different maintenance modes and ensuring that appropriate resource pools and affinity rules are in place to support graceful VM migration and restart. Question 12. What factors determine the optimal configuration of CPU and memory reservations, limits, and shares for virtual machines in a vSphere 6.7 environment to ensure both application performance and efficient resource utilization? Option A. Applying default reservation settings provided by VMware for all virtual machines to ensure a baseline level of performance. Option B. Increasing resource limits for all virtual machines to their maximum allowed values to prevent any potential resource contention. Option C. Analyzing real-time and historical performance metrics of virtual machines and hosts, understanding application resource demands and criticality, and considering the overall resource capacity of the vSphere cluster. Option D. Focusing solely on CPU performance metrics and ignoring memory utilization when configuring resource settings. The correct answer is C. Analyzing real-time and historical performance metrics of virtual machines and hosts, understanding application resource demands and criticality, and considering the overall resource capacity of the vSphere cluster. Explanation. This scenario presents a professional challenge in managing vSphere 6.7 environments by requiring a deep understanding of resource allocation and performance tuning, specifically concerning CPU and memory. The core difficulty lies in balancing the needs of diverse workloads with the finite resources of the underlying hardware, while adhering to best practices that ensure stability and efficiency. Professionals must make informed decisions that prevent resource contention, which can lead to application slowdowns, instability, and potential service disruptions. The regulatory framework for the 2V0-21-19D exam, while not explicitly detailing specific financial regulations for IT, implies a responsibility for efficient resource utilization and operational integrity, which indirectly impacts business continuity and cost-effectiveness. The correct approach emphasizes a data-driven methodology, leveraging vSphere's performance monitoring tools to identify actual resource utilization patterns and bottlenecks. This aligns with professional best practices by ensuring that resource allocation decisions are based on empirical evidence rather than assumptions. By analyzing metrics such as CPU ready time, memory ballooning, and swap usage, administrators can accurately pinpoint areas of contention and apply targeted adjustments. This proactive and analytical method minimizes the risk of over-provisioning, which wastes resources and increases costs, or under-provisioning, which degrades performance. It reflects a commitment to operational excellence and responsible IT resource management. An incorrect approach that relies solely on static, predefined resource reservations without considering dynamic workload behavior is professionally unacceptable. This fails to account for the fluctuating demands of applications, potentially leading to either wasted resources or performance degradation when actual demand exceeds reservations. Another incorrect approach, such as indiscriminately increasing resource limits across the board, ignores the principle of granular optimization. This can lead to unnecessary resource consumption, impacting the performance of other virtual machines and the overall host, and is a failure to apply professional judgment in resource management. A third incorrect approach, focusing only on CPU and neglecting memory, demonstrates an incomplete understanding of resource interdependence. Performance issues often stem from a combination of CPU and memory constraints, and a holistic view is essential for effective troubleshooting and tuning. Professionals should adopt a systematic decision-making process that begins with understanding the business requirements and application SLAs. This is followed by thorough performance monitoring and analysis to establish a baseline. Based on this data, targeted adjustments to resource configurations, reservations, limits, shares should be made, with subsequent monitoring to validate the effectiveness of these changes. This iterative process ensures that resource management is aligned with both technical performance goals and business objectives. Question 13. When evaluating the deployment of a critical security patch for vSphere 6.7 across a production environment, which approach best balances the need for immediate security remediation with the imperative to maintain service availability and data integrity? Option A. Apply the patch to a single, critical production host as a live test before rolling it out to other production systems. Option B. Delay the application of the patch indefinitely until a less disruptive time or until a more comprehensive upgrade is planned. Option C. Implement the patch on a representative subset of non-production virtual machines and hosts, thoroughly test functionality and performance, and then proceed with a phased rollout to production environments with rollback plans in place. Option D. Immediately apply the patch to all production virtual machines and hosts simultaneously to ensure all systems are secured as quickly as possible. Correct answer is C. Implement the patch on a representative subset of non-production virtual machines and hosts, thoroughly test functionality and performance, and then proceed with a phased rollout to production environments with rollback plans in place. Explanation. This scenario presents a professional challenge due to the inherent risk of data corruption and service disruption when performing critical infrastructure maintenance. The need to balance operational continuity with the imperative to implement security patches and updates is a common dilemma in IT environments. Careful judgment is required to select a method that minimizes risk while achieving the necessary security posture. The correct approach represents best professional practice because it prioritizes data integrity and service availability through a controlled, phased rollout. This aligns with general IT best practices for change management, which are implicitly supported by regulatory frameworks that mandate system availability and data protection. By testing in a non-production environment first, potential issues can be identified and mitigated before impacting live services. The subsequent phased rollout to production environments allows for monitoring and rapid rollback if unforeseen problems arise, thereby minimizing the blast radius of any potential failure. This methodical approach ensures compliance with the spirit of regulations that require robust and reliable IT systems. An incorrect approach that involves immediately applying the patch to all production hosts without prior testing fails to adhere to fundamental change management principles. This could lead to widespread service outages and data loss, potentially violating regulatory requirements for system uptime and data integrity. Such an action demonstrates a disregard for risk assessment and mitigation, which are core tenets of professional IT operations. Another incorrect approach, which involves delaying the patch indefinitely due to perceived complexity, creates a significant security vulnerability. This inaction exposes the environment to known exploits, which could result in a data breach or system compromise. Regulatory frameworks often mandate timely patching of known vulnerabilities to protect sensitive data and maintain system security. Failing to do so is a direct ethical and professional failing. A third incorrect approach, which involves applying the patch to a single, critical production host as a test, is also professionally unacceptable. While it involves some level of testing, it exposes a live, critical system to the risk of failure. If this single host fails, it could have a cascading impact on essential services, which is a more severe outcome than testing in a dedicated non-production environment. This approach bypasses the established practice of isolating testing from live operations. The professional reasoning process for similar situations should involve a thorough risk assessment, including evaluating the severity of the vulnerability being addressed, the potential impact of the patch, and the availability of testing environments. A change management process should be followed, which typically includes planning, testing, implementation, and post-implementation review. Professionals should always prioritize methods that minimize risk to data and service availability, adhering to established IT governance principles and any applicable regulatory mandates. Question 14. The risk matrix shows a high probability of performance degradation for a critical financial reporting application due to resource contention during peak processing periods. The application team has reported intermittent slowdowns and timeouts. You are tasked with resolving this issue within the vSphere 6.7 environment. Which of the following approaches best addresses this situation? Option A. Immediately migrate the virtual machine to a different host with more available resources, assuming the current host is overloaded. Option B. Analyze vSphere performance metrics for the affected virtual machine and its host, focusing on CPU ready time, memory ballooning, storage latency, and network throughput, to identify specific resource bottlenecks and implement targeted adjustments. Option C. Advise the application team to schedule their critical reporting jobs during off-peak hours to avoid periods of high resource utilization. Option D. Increase the allocated CPU and memory resources for the virtual machine significantly, without further investigation, to preemptively resolve any potential contention. The correct answer is B. Analyze vSphere performance metrics for the affected virtual machine and its host, focusing on CPU ready time, memory ballooning, storage latency, and network throughput, to identify specific resource bottlenecks and implement targeted adjustments. Explanation. The scenario presents a common challenge in virtualized environments, balancing performance optimization with resource allocation to meet diverse application demands. The professional challenge lies in accurately assessing the impact of resource contention on critical business applications, and making informed decisions that align with both technical best practices and potential regulatory compliance considerations. Even if not explicitly stated in the exam scope, the underlying principle of ensuring service availability and performance is paramount. Careful judgment is required to avoid overprovisioning, which wastes resources, or underprovisioning, which leads to performance degradation and potential business disruption. The correct approach represents best professional practice because it prioritizes a data-driven, systematic method for identifying and resolving performance bottlenecks. By analyzing performance metrics and understanding application behavior, a vSphere administrator can make targeted adjustments to resource allocation. This proactive and analytical method ensures that critical applications receive the necessary resources without negatively impacting other workloads. This aligns with the general professional responsibility to maintain a stable and performant IT infrastructure, which indirectly supports business continuity and operational efficiency. An incorrect approach that involves arbitrarily increasing resources without understanding the root cause is professionally unacceptable. This is because it leads to inefficient resource utilization, increased costs, and fails to address the underlying issue, potentially masking more significant architectural or configuration problems. It demonstrates a lack of analytical rigor and a failure to apply systematic troubleshooting methodologies. Another incorrect approach, such as migrating the application to a different host without proper analysis, bypasses the opportunity to understand and resolve the resource contention on the current host. This can lead to similar issues on the new host and indicates a reactive rather than proactive problem-solving strategy. It fails to leverage the diagnostic tools and capabilities within vSphere to identify and rectify the problem at its source. The professional reasoning process for similar situations should involve a structured approach. 1. Understand the reported issue and its business impact. 2. Gather relevant performance data from vSphere and the application itself. 3. Analyze the data to identify potential resource bottlenecks, CPU, memory, storage, network. 4. Formulate hypotheses about the root cause. 5. Test hypotheses through targeted adjustments or further investigation. 6. Implement solutions based on evidence. 7. Monitor the impact of the implemented solutions. 8. Document findings and actions taken. Question 15. Quality control measures reveal inconsistent virtual machine performance across multiple hosts within a vSphere 6.7 environment, with some VMs experiencing significant latency while others on the same hosts perform adequately. The underlying hardware configurations for the hosts are identical. The primary concern is to establish a stable and predictable performance baseline for all critical workloads. Option A. Increase the total available CPU and memory resources on all hosts to provide a larger buffer for all virtual machines. Option B. Implement Distributed Resource Scheduler, DRS, with a balanced automation level across all clusters to dynamically manage resource allocation and ensure optimal VM placement based on current demand. Option C. Periodically migrate virtual machines to different hosts based on observed performance metrics without a defined resource management policy. Option D. Manually adjust the CPU and memory reservations for individual virtual machines on an as-needed basis to address reported performance issues. The correct answer is B. Implement Distributed Resource Scheduler, DRS, with a balanced automation level across all clusters to dynamically manage resource allocation and ensure optimal VM placement based on current demand. Explanation. The scenario presents a common challenge in virtualized environments, ensuring consistent and reliable performance across different hardware configurations while adhering to best practices for resource management and operational efficiency. The professional challenge lies in balancing the immediate need for operational stability with the long-term implications of resource allocation and potential performance bottlenecks. Careful judgment is required to select a solution that is both technically sound and aligns with the principles of efficient resource utilization and system integrity. The correct approach represents best professional practice because it directly addresses the root cause of the performance variability by implementing a standardized and controlled method for resource allocation. This ensures that virtual machines receive predictable and adequate resources, minimizing performance fluctuations. This aligns with the general principles of IT best practices, which emphasize standardization, automation, and proactive management to maintain system health and user satisfaction. While the 2V0-21-19D exam focuses on vSphere 6.7, the underlying principles of resource management and performance optimization are consistent with industry standards for virtualization. An incorrect approach that involves manually adjusting resources on a per VM basis without a defined policy is professionally unacceptable. This ad hoc method leads to inconsistencies, is difficult to manage at scale, and can introduce new performance issues as the environment grows. It lacks the systematic approach required for robust IT operations and can be seen as a failure to implement proper change management and operational governance. Another incorrect approach that focuses solely on increasing the overall resource pool without targeted allocation is inefficient and costly. While it might temporarily alleviate performance issues, it does not address the underlying problem of uneven resource distribution. This can lead to wasted resources and increased operational expenses, failing to demonstrate fiscal responsibility and efficient resource management. A third incorrect approach that involves migrating VMs to different hosts without understanding the underlying resource contention is a reactive measure that does not solve the problem. It merely shifts the issue and can lead to performance degradation on the new hosts. This demonstrates a lack of root cause analysis and a failure to implement a sustainable solution. The professional reasoning process for similar situations should involve a systematic approach. 1. Identify and clearly define the problem. What are the observed performance issues and their symptoms? 2. Gather data. Collect relevant metrics from vSphere host hardware and guest operating systems. 3. Analyze the data. Determine the root cause of the performance variability. Is it CPU contention, memory pressure, storage I/O, or network saturation? 4. Evaluate potential solutions. Consider various technical and operational approaches. 5. Select the most appropriate solution. Choose the option that best addresses the root cause, is scalable, cost-effective, and aligns with best practices. 6. Implement and monitor. Deploy the chosen solution and continuously monitor its effectiveness. 7. Document and refine. Record the changes made and lessons learned for future reference. Question 16. The evaluation methodology shows a vSphere administrator is tasked with selecting a new storage solution for a mission-critical production environment that hosts financial transaction processing. The administrator has identified three potential solutions: a high-performance, high-costs and array, a cost-effective NAS solution with adequate capacity but unproven performance under heavy transactional load, and a hyperconverged infrastructure (HCI) solution that integrates compute and storage but requires significant upfront investment and a learning curve for the existing team. Which approach best aligns with professional best practices for ensuring the integrity, performance, and recoverability of this sensitive production workload? Option A. Select the cost-effective NAS solution, assuming its stated capacity is sufficient and implementing a basic backup strategy to mitigate potential performance issues. Option B. Choose the NAS solution based on its lower cost, assuming that any performance limitations can be addressed through future software optimizations and that the existing backup solution is adequate. Option C. Implement the HCI solution, focusing on rapid deployment to minimize disruption and relying on vendor support for initial configuration and ongoing management. Option D. Prioritize the high-performance and array, conducting thorough performance benchmarking and failover testing to validate its suitability for the transactional workload and ensure robust disaster recovery capabilities. The correct answer is D. Prioritize the high-performance and array, conducting thorough performance benchmarking and failover testing to validate its suitability for the transactional workload and ensure robust disaster recovery capabilities. Explanation. The evaluation methodology shows a scenario where a vSphere administrator is tasked with implementing a new storage solution for a critical production environment. This scenario is professionally challenging because the decision directly impacts the availability, performance, and recoverability of business-critical applications. Misjudging the storage solution could lead to significant downtime, data loss, and reputational damage, all of which have severe financial and operational consequences. The administrator must balance technical requirements with business needs and adhere to established best practices and potential regulatory considerations, even if not explicitly stated in the prompt, as data integrity and availability are often implicitly governed by compliance frameworks. The correct approach represents best professional practice because it involves a thorough, multifaceted evaluation that prioritizes data integrity, performance, and recoverability. This includes understanding the specific workload characteristics, assessing the capabilities of different storage technologies, e.g., NAS, vSAN, against those requirements, and critically, validating the chosen solution through rigorous testing in a non-production environment. This methodical approach ensures that the chosen storage solution meets the demanding needs of the production environment and aligns with the organization's overall IT strategy and risk tolerance. It demonstrates due diligence and a commitment to operational excellence. An incorrect approach that focuses solely on cost reduction without adequate performance or reliability testing would be professionally unacceptable. This failure would violate the implicit ethical obligation to ensure the stability and integrity of the production environment. Such a decision could lead to performance bottlenecks, data corruption, or extended downtime, directly contravening the principles of responsible IT management. Another incorrect approach, such as implementing a solution based on vendor marketing claims without independent verification or proof-of-concept testing, represents a failure in due diligence. This can result in unexpected compatibility issues or performance degradation, exposing the organization to unnecessary risk and potentially violating service-level agreements, SLAs, if they exist. Relying on outdated or unsupported technologies without a clear upgrade path is also a failure, as it introduces security vulnerabilities and limits future scalability, impacting long-term business continuity. Professionals should employ a decision-making framework that begins with a clear understanding of business requirements and technical constraints. This is followed by a comprehensive research and evaluation phase, considering multiple viable solutions. Proof-of-concept testing and performance benchmarking are crucial steps to validate assumptions and identify potential issues before production deployment. Finally, a risk assessment should be conducted to understand the potential impact of each option and to inform the final decision, ensuring alignment with organizational policies and best practices for data management and system availability. Question 17. The audit findings indicate that the vSphere 6, 7 environment is not optimally configured for storage resilience, specifically regarding the handling of data store accessibility issues. The current configuration relies on manual intervention for data store recovery, which has led to prolonged virtual machine downtime in the past. The auditor has flagged this as a significant risk to business continuity. Which of the following actions best addresses the audit finding and aligns with vSphere 6? 7 best practices for storage management and high availability. Option A. Manually reconfigure the multipathing policies for all data stores to a less aggressive setting to reduce the frequency of data store accessibility alerts. Option B. Implement storage DRS to automate the balancing of virtual machine disk I/O across available data stores, thereby improving performance and availability during periods of high load or data store degradation. Option C. Disable the data store accessibility checks within vCenter server to prevent false positives and reduce the number of alerts generated by the monitoring system. Option D. Configure the data stores to use a single, highly available storage array and ensure all virtual machines are configured with redundant network paths to the storage. The correct answer is B. Implement storage DRS to automate the balancing of virtual machine disk I/O across available data stores, thereby improving performance and availability during periods of high load or data store degradation. Explanation: the audit findings indicate a potential misconfiguration in vSphere 6.7 that could impact the availability and integrity of virtual machines, specifically concerning the management of storage resources. This scenario is professionally challenging because it requires a deep understanding of vSphere storage best practices and the implications of various configuration choices on data protection and performance. The auditor's concern highlights the critical need for administrators to implement robust storage management strategies that align with business continuity objectives and regulatory compliance, even in a Delta exam context, which focuses on recent changes and common pitfalls. The correct approach represents best professional practice because it directly addresses the audit finding by implementing a solution that enhances storage resilience and manageability without introducing new risks. This involves leveraging vSphere's native capabilities for storage management in a way that is documented, tested, and aligned with the organization's overall IT strategy. Adhering to VMware's recommended configurations and best practices ensures that the environment remains supportable, secure, and performant, thereby mitigating future audit findings and operational disruptions. An incorrect approach that involves disabling critical storage features or implementing ad hoc solutions without proper testing and documentation would represent a significant regulatory and ethical failure. Such actions could lead to data loss, extended downtime, and a failure to meet service-level agreements, SLAs, which are often subject to regulatory oversight and contractual obligations. Furthermore, deviating from established best practices without a clear, documented justification and risk assessment demonstrates a lack of due diligence and professional responsibility, potentially exposing the organization to financial penalties and reputational damage. Another incorrect approach might be to ignore the audit finding altogether, which is a clear abdication of responsibility and a direct violation of professional ethics, as it allows known risks to persist. The professional reasoning process for similar situations should involve a thorough understanding of the audit finding, a comprehensive assessment of the current vSphere configuration, and an evaluation of potential remediation strategies against established best practices and organizational policies. This includes consulting official VMware documentation, considering the impact on other vSphere components, and performing rigorous testing in a non-production environment before implementing changes in production. A proactive approach to identifying and mitigating risks, coupled with clear communication with stakeholders, is paramount to maintaining a secure and reliable virtualized infrastructure. Question 18. The evaluation methodology shows a vSphere administrator is responsible for implementing a new, stringent security policy across a vSphere 6.7 environment that mandates specific network access controls and virtual machine hardening standards. The administrator has identified several potential methods for deployment. Which approach best balances security objectives with operational continuity and minimizes risk to the production environment? Option A. Immediately apply the new security policy to all virtual machines in the production environment to ensure uniform security coverage as quickly as possible. Option B. Apply the policy to production virtual machines during a scheduled maintenance window, but without any prior testing on non-production systems. Option C. Deploy the new security policy to a small subset of non-production virtual machines first, closely monitor the impact, and then proceed with a phased rollout to production environments based on successful testing. Option D. Implement the policy using only automated scripts without any manual verification, assuming the scripts are correctly written. The correct answer is C. Deploy the new security policy to a small subset of non-production virtual machines first, closely monitor the impact, and then proceed with a phased rollout to production environments based on successful testing. Explanation. The evaluation methodology shows a scenario where a vSphere administrator is tasked with implementing a new security policy across a vSphere 6.7 environment. This presents a professional challenge due to the potential for unintended consequences, such as service disruptions or security vulnerabilities, if the policy is not applied correctly or if it conflicts with existing configurations. The need for careful judgment arises from balancing the security requirements with the operational stability of the virtual infrastructure. The correct approach involves a phased rollout of the security policy, starting with a pilot group of non-production virtual machines. This represents best professional practice because it aligns with the principle of minimizing risk. By testing the policy in a controlled environment, the administrator can identify and rectify any issues before they impact critical production systems. This proactive approach is crucial for maintaining service availability and data integrity, which are fundamental ethical obligations for IT professionals. Furthermore, thorough documentation of the policy, its implementation steps, and the testing results ensures transparency and accountability, adhering to best practices for change management and compliance. An incorrect approach would be to immediately apply the new security policy to all virtual machines in the production environment without prior testing. This failure represents a significant regulatory and ethical lapse. It demonstrates a disregard for the potential impact on business operation, violating the duty to maintain system stability and availability. Such an action could lead to widespread service outages, data loss, and reputational damage, all of which have serious implications for the organization and could contravene service-level agreements or internal compliance mandates. Another incorrect approach would be to implement the policy without consulting relevant stakeholders, such as application owners or security teams. This oversight is a failure in professional communication and collaboration. It can lead to the implementation of a policy that is technically sound but operationally disruptive, or that creates new security gaps by not considering the broader context of the IT environment. Ethical considerations demand that decisions impacting multiple systems and teams are made with informed consent and input from all affected parties. A third incorrect approach would be to rely solely on automated tools to apply the policy without any manual verification or validation. While automation is valuable, over-reliance without human oversight can mask underlying configuration errors or policy misinterpretations. This can lead to the incorrect application of security settings, potentially weakening the security posture or causing system instability. Professional decision-making in such situations requires a balanced approach, leveraging automation for efficiency while retaining human judgment for validation and critical decision points. The professional reasoning framework for this situation involves a risk-based approach. First, assess the potential impact of the proposed change. Second, develop a detailed implementation plan that includes testing, rollback procedures, and communication strategies. Third, execute the plan in a controlled manner, prioritizing non-production environments for initial deployment. Fourth, monitor the implementation closely and be prepared to respond to any issues. Finally, document all actions and outcomes for future reference and auditing. Question 19. The monitoring system demonstrates a consistent and significant spike in CPU utilization on a primary XC host serving multiple production virtual machines. This spike is causing noticeable performance degradation for several critical applications. What is the most appropriate initial course of action to diagnose and address this issue? Option A. Disable non-essential services running on the XC host to reduce its resource overhead. Option B. Immediately reboot the XC host to clear any transient resource contention. Option C. Initiate a vMotion of all virtual machines from the affected XC host to other hosts in the cluster. Option D. Access the ESXi host's performance charts and analyze CPU usage by virtual machine and by ESXi process to identify the primary consumer of resources. The correct answer is D. Access the ESXi host's performance charts and analyze CPU usage by virtual machine and by ESXi process to identify the primary consumer of resources. Explanation. The monitoring system demonstrates an unusual pattern of high CPU utilization on a critical vSphere host, impacting virtual machine performance. This scenario is professionally challenging because it requires immediate action to restore service, while adhering to operational best practices and potentially regulatory compliance related to service availability and data integrity, even though specific regulations for this exam are focused on the technical framework of vSphere 6. 7. The core challenge lies in diagnosing the root cause without introducing further instability or violating established operational procedures. The correct approach involves a systematic, non-disruptive investigation. This means leveraging vSphere's built-in diagnostic tools and performance metrics to pinpoint the source of the CPU contention. This could involve analyzing performance charts for specific virtual machines, ESXi processes, or hardware issues. The professional best practice is to isolate the problem without immediately resorting to drastic measures like rebooting the host, which could lead to data loss or service interruption for other VMs. This methodical approach aligns with the principles of maintaining system stability and minimizing operational risk, which are implicit in professional IT operations. An incorrect approach would be to immediately reboot the ESXi host without prior investigation. This is professionally unacceptable because it bypasses the diagnostic process, potentially masking the underlying issue and leading to its recurrence. It also risks disrupting services for all virtual machines hosted on that ESXi, violating the implicit professional obligation to maintain service availability. Another incorrect approach would be to indiscriminately migrate all virtual machines off the host without understanding the cause of the CPU spike. A migration can be a valid remediation step. Doing so without diagnosis is inefficient and could overload other hosts if the issue is widespread or if the migration process itself consumes significant resources. A third incorrect approach would be to disable specific virtual machine features or services without understanding their role in the CPU utilization. This could lead to unintended consequences and further service degradation. The professional decision-making process for similar situations should involve a tiered approach. First, observe and gather data using available tools. Second, analyze the data to form hypotheses. Third, test hypotheses with the least disruptive methods. And finally, implement remediation based on confirmed root cause. This systematic process ensures that actions are informed, targeted, and minimize negative impacts on the production environment. Question 20. Quality control measures reveal that a critical virtual machine is exhibiting intermittent performance degradation and generating unusual log entries. The virtual machine hosts a core business application. The vSphere environment is configured for high availability and disaster recovery. What is the most appropriate immediate action to take? Option A. Attempt an in-place repair of the virtual machine's operating system and applications. Option B. Continue monitoring the virtual machine and wait for the issue to resolve itself. Option C. Initiate a rollback of the virtual machine to a recent, known good snapshot. Option D. Immediately disable the virtual machine to prevent further issues. Correct answer is C. Initiate a rollback of the virtual machine to a recent, known good snapshot. Explanation. This scenario presents a challenge in maintaining the integrity and availability of a virtualized environment while adhering to operational best practices and potential compliance requirements. The core difficulty lies in balancing the need for immediate remediation of a detected issue with the potential impact on ongoing operations and data consistency. Careful judgment is required to select a solution that minimizes risk and disruption. The correct approach represents best professional practice because it prioritizes a controlled and validated rollback strategy. This aligns with established IT service management principles, such as those found in ITIL, which emphasize minimizing the impact of changes and having robust rollback plans. In a professional vSphere environment, this approach ensures that the system is returned to a known stable state, reducing the risk of cascading failures or data corruption. It also allows for more thorough investigation of the root cause in a controlled manner, preventing further degradation. while the exam syllabus for 2V0-21 19D focuses on vSphere technical aspects. The underlying principle of risk mitigation and controlled remediation is a fundamental professional expectation. An incorrect approach that involves immediately disabling the affected virtual machines without a clear rollback plan or investigation fails to address the root cause and could lead to unexpected dependencies being broken, impacting other services. This demonstrates a lack of systematic problem solving and a disregard for the interconnectedness of a virtual infrastructure. Another incorrect approach, such as attempting a complex in-place repair without proper testing or validation, introduces significant risk of further system instability or data loss. This bypasses established change management and testing protocols, which are crucial for maintaining a reliable production environment. A third incorrect approach, which involves ignoring the alert and continuing operations, is a direct abdication of professional responsibility. It allows a known issue to persist, increasing the likelihood of more severe failures and potential data breaches or service outages, which could have significant operational and reputational consequences. Professionals should employ a decision-making framework that includes understanding the reported issue and its potential impact, assessing available remediation options, evaluating the risks and benefits of each option, consulting relevant documentation and support resources, and implementing the chosen solution with a clear plan for monitoring and validation. In this case, a phased approach involving investigation, controlled rollback, and then root cause analysis is the most prudent.